Hello everyone, welcome to Succeed e-learning app. Today we are going to learn about trigonometry, chapter 11, Introduction to Trigonometry. Hello students, I hope you have learnt about different kinds of triangles, particularly right angle triangles in your earlier classes. Today we are going to take an example from our surrounding where a right angle triangle can be formed. Consider an example where a girl standing on the ground flying a kite very high from the ground perpendicular to the ground. The distance between the kite to the hand of the girl is called hypotenuse, and the line joining the perpendicular to the base of the hypotenuse is called the adjacent side. And the side opposite to the hypotenuse and adjacent is called the opposite side. In this scenario, the distance can be calculated from a mathematical technique called trigonometry, where the trigonometry word is derived from a Greek word where tri means 3, gon means side, and metron means measurement. So in general, trigonometry means measurement of triangles. In fact, trigonometry is the relationship between the sides and angles of a triangle dealing with the right angle triangle. Trigonometric ratios. Hello students, I hope you have learned or understood the basic concept of trigonometry. Now, let us learn about the trigonometric ratios which can be formed. Consider a right angle triangle ABC where the right angle is at the B. Let us name the sides as AB as A, BC as B, and AC as C. So, let us make it more clearer. Let us call AC as hypotenuse, AB as opposite side, and BC as the adjacent side. Sine of A is equal to side opposite to the theta divided by hypotenuse, AB by AC. Cosine theta is equal to side adjacent to the angle theta divided by hypotenuse. Tan theta is equal to AB by AC. Cosine theta is equal to 1 by sine A, which is equal to AC by AB. Secant theta is equal to AC by BC, and cot theta is equal to 1 by tan theta, which is equal to BC by AB. The ratios defined above can be abbreviated as sin theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta respectively. Note that cosecant theta, cot theta, and secant theta are the reciprocals of sin theta, cos theta, and tan theta. Now, let us consider an example to understand the concept better. In triangle ABC, right angle at C in which AB is equal to 15 units, BC is equal to 12 units, and angle ABC is equal to theta. Determine the value of cos square theta plus sin square theta. Now, we need to find the side AC by using Pythagoras theorem. AB square is equal to BC square plus AC square. 15 the whole square is equal to 12 square plus AC square. 225 is equal to 144 plus AC square. 225 minus 144 is equal to AC square. 81 is equal to AC square. AC is equal to root 81. AC is equal to 9 units. Now, sin theta is equal to AC by AB, which is equal to 9 by 15, and cos theta is equal to BC by AB, which is equal to 12 by 15. Now, we will find cos square theta plus sin square theta. Cos square theta plus sin square theta is equal to 12 by 15 the whole square plus 9 by 15 the whole square, which is equal to 12 whole square plus 9 square divided by 15 square, which is equal to 225 divided by 225, which is equal to 1, which means cos square theta plus sin square theta is equal to 1. Similarly, we can find cos square theta minus sin square theta by this method. Similarly, we can try to define the trigonometric ratios for angle A in a right angle triangle. Now, we have defined 6 trigonometric ratios of an acute angle triangle. If we know any of the ratios, can we obtain the other ratios? Let us see with an example. In a right angle triangle ABC, sin A is equal to 3 by 5, find the other trigonometric ratios. Let us draw a right angle triangle. Now, we know that sin A is equal to BC by AC, which is equal to opposite by hypotenuse, which is equal to 3 by 5. We have already learnt Pythagoras theorem in previous lesson. By using it, we will find the other unknown sides AB. By Pythagoras theorem, we have AC square is equal to AB square plus BC square. Here, we have AC is equal to 5 and BC is equal to 3. Substitute the values in the equation given above. 5 square is equal to AB square plus 3 square, 25 is equal to AB square plus 9, 25 minus 9 is equal to AB square, 16 is equal to AB square, AB is equal to root of 16, AB is equal to 4 units. The other side AB value is 4. Now, by all the values we can find the other trigonometric ratios. Let us find values of other trigonometric ratios. AB by AC is equal to adjacent by hypotenuse. Now adjacent or AB is equal to 4 and AC is equal to 5. Cos A is equal to 4 by 5. Tan A is equal to BC by AB, which is equal to 3 by 4. Therefore, cosecant A is equal to 1 by sin A, which is equal to 5 by 3. Secant A is equal to 1 by cos A, which is equal to 5 by 4. And cot A is equal to 1 by tan A, which is equal to 4 by 5. So, these are the values of all trigonometric ratios. Trigonometric ratios of some specific angles. Hello students, I hope you all are already familiar with the construction of angles of 30 degree, 45 degree, 60 degree and 90 degree. And in this section, we will find the values of trigonometric ratios for these angles and also for angle 0 degree. Trigonometric ratio of 45 degree. In triangle ABC, right angle at B, if one angle is 45 degree, then the other angle is also 45 degree. Angle A is equal to angle C is equal to 45 degree. Hence, BC is equal to AB because isosceles triangle theorem. BC is equal to AB is equal to A. Then by Pythagoras theorem, AC square is equal to AB square plus BC square, AC square is equal to A square plus A square, AC square is equal to 2A square, AC is equal to A root 2. So, we got the value of AC as A root 2. Now, by using the definitions of the trigonometric ratios, we have sin 45 degree is equal to side opposite to angle 45 degree by hypotenuse, which is equal to BC by AC, A by A root 2, which is equal to 1 by root 2. So, sin 45 degree is equal to 1 by root 2. Now, let us find cos 45 degree. Cos 45 degree is equal to side adjacent to the angle 45 degree divided by hypotenuse, which is equal to AB by AC, which is equal to A by A root 2. So, cos 45 degree is equal to 1 by root 2. Similarly, we will now find the value of tan 45 degree. Tan 45 degree is equal to side opposite to the angle 45 degree divided by side adjacent to the angle 45 degree. BC by AB, which is equal to A by A. So, tan 45 degree is equal to 1. Now, we know that cosecant A, secant A, cot A are respectively reciprocals of sin A, cos A and tan A. Therefore, it is very easy to find out the values of cosecant 45 degree, secant 45 degree and cot 45 degree. Now, let us find it out. Cosecant 45 degree is equal to 1 by sin 45 degree, which is equal to 1 by root 2. Cosecant 45 degree is equal to root 2. Now, let us find secant 45 degree. Secant 45 degree is equal to 1 by cos 45 degree, which is equal to 1 by root 2. Secant 45 degree is equal to root 2. Now, let us find cot 45 degree. Cot 45 degree is equal to 1 by tan 45 degree, which is equal to 1. So, trigonometric ratios of 45 degree are displaying all this on the screen. Sin 45 degree is equal to 1 by root 2. Cos 45 degree is equal to 1 by root 2. Tan 45 degree is equal to 1. Similarly, cosecant 45 degree is equal to root 2, secant 45 degree is equal to root 2, cot 45 degree is equal to 1. Now, let us learn trigonometric ratios of 30 degree and 60 degree. Consider an equilateral triangle ABC. Since each angle is an equilateral triangle is 60 degree, therefore, angle A is equal to angle B is equal to angle C is equal to 60 degree. Draw a perpendicular AD to the side BC. Triangle ABD is congruent to triangle ACD by SAS postulate. BD is equal to DC, angle BAD is equal to angle CAD. Now observe that here triangle ABD is a right angle triangle at angle D with angle BAD is equal to 30 degree and angle ABD is equal to 60 degree. As all of know, for finding the trigonometric ratio, we need to know the lengths of the sides of the triangle. Consider AB is equal to 2A, then BD is equal to 1 by 2 of BC, which is equal to A. By applying Pythagoras theorem, AD square is equal to AB square minus BD square, 2A the whole square minus A square, which is equal to 3A square. AD is equal to A root 3. Now, we have sin 30 degree is equal to BD by AB, which is equal to A by 2A, sin 30 degree is equal to 1 by 2. Similarly, cos 30 degree is equal to AD by AB, that is adjacent by hypotenuse, A root 3 by 2A, that is equal to root 3 by 2. Tan 30 degree, BD by AD, which is equal to A by A root 3, which is equal to 1 by root 3. Therefore, also we can find this cosecant 30 degree is equal to 1 by sin 30 degree, which is equal to 2. Secant 30 degree is equal to 1 by cos 30 degree, which is equal to 1 by root 3 by 2, which is equal to 2 by root 3. Cot 30 degree is equal to 1 by tan 30 degree is equal to 1 by root 3, which is equal to root 3. Similarly, now we need to find for angle 60 degree. So, for angle B is equal to 60 degree, sin 60 degree is equal to AD by AB is equal to A root 3 by 2A is equal to root 3 by 2. Cos 60 degree is equal to BD by AB, which is equal to A by 2A, which is equal to 1 by 2. Tan 60 degree is equal to AD by BD is equal to A by root 3, which is equal to root 3. Similarly, the reciprocals cosecant 60 degree is equal to 2 by root 3, secant 60 degree is equal to 2 and cos 60 degree is equal to 1 by root 3. Now, let us learn trigonometric ratios of 0 degree and 90 degree. Let us see what happens to the trigonometric ratio of angle A if it is made smaller and smaller in a right angle triangle till it becomes 0. As angle A gets smaller and smaller, the length of the side BC decreases. The point C gets closer to point B, and finally, when angle A becomes very close to 0 degree, AC becomes almost same as AB. When angle A is very close to 0, BC gets very close to 0. So, the value of sin A is equal to BC by AC is very close to 0. Sin A is equal to BC by AC, which is equal to 0. Also, when angle A is very close to 0, AC is nearly same as AB, and so the value of cos A is equal to AB by AC is very close to 1. Hence, cos A is equal to AB by AC, which is equal to 1. Similarly, tan 0 is equal to sin 0 by cos 0, which is equal to 0. Cot 0 is equal to 1 by tan 0, which is equal to 1 by 0, which is not defined. Secant 0 is equal to 1 by cos 0, which is equal to 1. Cosecant 0 is equal to 1 by sin 0, which is also equal to 1 by 0, which is also not defined. Now, let us see what happens to the trigonometric ratio of angle A when it is made larger and larger till it becomes 90 degree. As angle A gets larger and larger, angle C gets smaller and smaller. So, the side AB goes on decreasing. The point A gets closer to point B. Finally, when angle A is very close to 90 degree, angle C becomes very close to 0 degree and the side AC almost coincide with the side BC. When angle C is very close to 0, angle A is very close to 90 degree. Side AC is nearly same as side BC, and sin A is close to 1 and cos A is very close to 0. So, we can define it as sin 90 is equal to 1, cos 90 is equal to 0. By using these values, we can find other trigonometric ratios. Tan 90 is equal to sin 90 divided by cos 90, which is equal to 1 by 0, which is not defined. Cot 90 is equal to cos 90 by sin 90, which is equal to 0. Let us see the table of all trigonometric ratios. Displaying the table. The table consists of angle A, for which the angles are 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Let us see the trigonometric ratios for this. Sin A, sin 0 degree is equal to 0, sin 30 degree is equal to 1 by 2, sin 45 degree is equal to 1 by root 2, sin 60 degree is equal to root 3 by 2, sin 90 degree is equal to 1. Cos 0, cos 0 is equal to 1, cos 30 degree is equal to root 3 by 2, cos 45 degree is equal to 1 by root 2, cos 60 degree is equal to 1 by 2, cos 90 degree is equal to 0. Tan of 0 is equal to 0, tan 30 is equal to 1 by root 3, tan 45 degree is equal to 1, tan 60 degree is equal to root 3, tan 90 degree is equal to not defined. Cosecant 0, which is not defined, cosecant 30 degree is equal to 2, cosecant 45 degree is equal to root 2, cosecant 60 degree is equal to 2 by root 3, cosecant 90 degree is equal to 1. Secant 0 is equal to 1, secant 30 degree is equal to 2 by root 3, secant 45 degree is equal to root 2, secant 60 degree is equal to 2, secant 90 degree is not defined. Cot 0 is equal to not defined, cot 30 degree is equal to root 3, cot 45 degree is equal to 1, cot 60 degree is equal to 1 by root 3, cot 90 degree is equal to 0. These are very important values to find the practical solutions in trigonometry. From the table, we can observe that as angle A increases from 0 to 90 degree, sin A increases from 0 to 1 and cos A decreases from 1 to 0. So, here we complete the chapter. For more information, please log into Sslc e-learning app. Thank you.